Hello everyone, welcome to part 3 of learning opencv, and the link for part 1 and part 2 will be given in the description. So the next topic I want to take is how you can blend or how you can merge two images using the pyramid scheme. Okay, now here we have imported the libraries which are required, and here we have read two images. One is apple image and one is the orange image. So let me just show you both the images very quickly, apple image and orange image. So let's come back to the code, and I'm showing them both on the screen using the ImShow function, and Apple image is the display window, orange image is the display window for the orange. Now, wait key for 0 means it will stay there for unlimited period of time unless we close the window. And then the last function which we are going to use is destroy all methods, which will destroy both of these windows which we are showing on the screen. So let me just save it, and let's very quickly run this file, and you'll be able to see both the images. One is the apple image and another one is the orange image. So now let me just click on the escape button, and both images windows will be destroyed like this. Okay, now just for understanding purpose, okay, let me just print the shape of the apple image APPLE, as well as let's print the orange image shape. Now let me just save it once again, and let me rerun the program. So as you can see, both the images are 512 by 512 and in three channels, red, green and blue. So that's why you're getting here this has three. Now let me go back to the images and just press escape button, and we can stop the program like this. And now I want to blend both the images together, half of the apple image and half of the orange image. So like this, let me say that I want to uh, put them on one top of another, but half of the apple image and half of the orange image. So for that, what we need to do is we need to use the numpy's horizontal stack method, h stack method, and here we will have to pass both the images. So let me pass it like a tuple. So one is the apple image, another one is the orange image, and in the apple image, okay, you have to consider all the row wise as well as the column wise what you want to take. Okay, row wise I want to take all the features. Okay, and here I want to take only till the 256 pixel like this. And for the same orange also, I will keep all the rows. Okay, and this should start from 256 pixel to till the last. Okay, so this is how you can stack them one next to each other. And here let me say like stacked, or I can just name it as blended image. Blended image is equal to like this. And now what we are going to do is we are going to show them on the screen just like this sentence which we have used here. Okay, cv2.im.show. Here let me name the window as a blended image, and here we will pass that variable blended image like this. So let's save the program and let's run it very quickly. So as you can see, we got the third window. Okay, the third image, this is the apple image, this one is the orange image, and this is the blended image. Here as you can see, the title which we have given for this particular window is blended image. Okay, so this is how it has started from 256 till the end. The apple image started from 0 till 256, and that is why we are seeing this exact line at 256. I have taken exactly the half of 512 and put it as 256. So this is how you can blend, but still when you are blending this, okay, you will be able to see this particular line exactly at the middle. Okay, so in order to get rid of this, okay, we are going to use some blending properties. Okay, and we are going to use the pyramid methods which we discussed in part 2. So in order to blend both of these images using the pyramids, okay, first let me write down the steps which you have to follow, the main 5 steps which you have to follow to do this. Okay, so very quickly let me write down the steps to blend the images using pyramids. Okay, the 5 steps, let me write it here as 5 steps. So here I have written down those 5 steps. So first you have to load the two images which you are trying to blend. Then you have to find the Gaussian pyramid of both the apple and the orange image. And the third step is from the Gaussian pyramids itself, we will have to find the Laplacian pyramid for each and every image. And then the next part is to join the left half of the apple image with the right half of the orange image in each of those levels of the Laplacian pyramid. Okay, and then the final step remains is how to join both the images, pyramids, and reconstruct the original image back from the Laplacian pyramid itself. So step by step, we are going to perform all these 5 operations. So here, first step, we have a red, that is, we have loaded the both the images which we are trying to blend. So let me write it here in comments that this is the step one. Let me write here step one, loading the images. Okay, so step one is complete. Now let's do step number two. So let me write it here in comment. Step two is building the Gaussian pyramid. Gaussian, Gaussian, and we'll be having a Gaussian pyramid for the apple image, and we'll be having like six layers of that. And let me keep a variable here called as apple copy. Okay, I'm going to keep a variable called as apple underscore copy, and we are going to copy the original apple image using the copy function into this particular variable. Now, simply for Gaussian pyramid, I'll keep the variable name as gp underscore apple, and I'm going to use a list and pass the apple underscore copy inside that one. Okay, so this is how we have creating we are creating a list of parameters of the apple underscore copy image into this variable gp underscore apple. So now since I want 6 layers of the apple image, so I'll put it in a for loop saying that for I in range, let me just pass it at 6, so it will start from 0 to 5, and from this apple dot copy image, okay, apple dot copy image, okay, I want to use the pyramid down function on this particular variable. Okay, see, from this variable itself we are going to have 6 layers. So from cv2 library itself, okay, there is a function called as pyr down. So down function, and inside that down function I am going to put this variable and store the result in this variable itself, apple underscore copy itself. It's like reloading all the features of apple underscore copy image into layers and putting them back in that variable itself. It's like updating those values. Okay, next what I'm going to do is here this variable which we have taken as a list. So let me just grab this very quickly. Okay, and I'm going to append all the values which we have got from this particular variable. Okay, the 6 layer variables. So let me just paste it over here and done. So this is how we are creating. So this 5 lines of code is how we are going to create a Gaussian pyramid of the apple image. And just like this only, let me just create the same 6 layers of the orange image. So let me just come here and change this name to orange. Okay, and we are going to be building a Gaussian pyramid of the orange image. So let me just keep the same name like this, orange underscore copy, and here we'll copy to orange. Okay, orange image we are going to copy, and this variable I'm going to keep it as Gaussian pyramid orange, and here also let me change this to orange underscore copy. So first we are going to use a for loop, and then just like the previous thing, we are going to change this to orange underscore copy, and here also in the pyramid down function we are going to say orange underscore copy function. That's it, like this. Okay, and finally let's append those values in the orange pyramid. So let me change this name also to orange, and we are done with the code. Okay, so this is the step 2 of building Gaussian pyramid, okay, on both the images, that is the apple and the orange images. Now here we have found the Gaussian pyramids for apple and orange images. Okay, now the third step is from the Gaussian pyramid itself we have to find the Laplacian pyramid for these two images. So let me come here and write it in comment like step 3 from Gaussian pyramid we are going to find the Laplacian pyramids like this. So now first of all what we are going to do is same thing, apple underscore copy variable is there. Okay, in that one we are going to store gp underscore apple. And now how to find Laplacian pyramid is at any level of Gaussian pyramid is the one level of Gaussian pyramid, okay, subtracted by its next level. Okay, the difference between the next level or the higher level of a Gaussian pyramid is going to give us one level of Laplacian pyramid. Now you have to know that since in Gaussian pyramids we have taken six layers, and if I start subtracting one layer from the another layer, so at the end we are going to end up with only five layers. So that's why we are going to have five of the Gaussian pyramid apple. Okay, so that's why we are giving it as five. And now to create Laplacian variable, so I'll simply name it as Laplacian LP underscore, and this will be Laplacian pyramid for apple. So let me just keep the variable as LP underscore apple is equal to, and I'm going to create a list in which we are going to pass our apple underscore copy variable like this. Okay, so this is the image on which we are going to find the Laplacian pyramid for. Okay, now what we have to do is we have to use a for loop. Okay, I in a range. Okay, but this time since I'm subtracting from the higher layer to the lower layer, so I'll start my loop from 5 and end it till 0 in reverse order. So you have to give it as -1 here. So -1 makes it come in reverse order. So now what we have to do is we have to say, let me create a variable first, Gaussian Gaussian underscore expanded like this. And from CV2 library, I'm going to use the pyramid up function now. Okay, pyramid up function from this GP underscore apple of each layer of I. Okay, so this is going to give me each layer of Gaussian pyramid which is got extended. Now to create the Laplacian pyramid, okay, so I'm going to use a variable called as Laplacian, and from CV2 library there is a function called as subtract. I'm going to use that, and from the Gaussian pyramid, okay, that is gp dot apple, from the I value, that is 5 minus 1, then again 4 minus 1, 3 minus 1, like this. It is going to keep subtracting one layer from that. And here what we will have to do, we will have to pass the main variable Gaussian extended uh, as the second argument. So this is how we are going to form, this is how we are going to find the Laplacian pyramid. Okay, and then finally all this Laplacian pyramid I will append it inside the variable lp underscore apple dot, let me use the append method and say this variable Laplacian you keep on appending in this particular variable. Okay, so this is how you create a Laplacian pyramid for from the Gaussian pyramid of apple. So just like this itself, I'm going to copy this whole code and paste it over here and create a Laplacian pyramid for the orange image as well. So let me just make this as orange copy underscore copy, and here instead of gp apple I will say gp orange. So this is the variable name which we want to keep. Then Laplacian orange variable is equal to whatever the orange image we have copied over here like this. And now here we'll just change this one parameter that is called as gp underscore orange. Same way here also gp underscore orange Gaussian expanded, and then lp orange you append all the values of the Laplacian pyramid which we have found for the orange image. Now we have finished all the three steps. Now let's come to the fourth step. Let me write it here. Okay, the fourth step is nothing but joining the two halves of the pyramid from the apple and the orange image. So let me write it here. Okay, so we are joining the apple half image and orange half image in each levels of Laplacian pyramid. Okay, so that is what we are going to do. So now let me just create a variable called as apple underscore orange underscore like merged or something like that. Okay, and then let's at the beginning let me keep this as empty list, empty empty list. Okay, now what we are going to do is we are going to use the zip function. Okay, we are going to use the zip function for all the levels of orange and apple levels. Okay, so I'll write it in for loop saying that we have the apple underscore Laplacian, okay, comma, and orange underscore Laplacian. I'm going to take two variables like I comma j. Okay, and then in I'm going to use the zip function to combine, means lp underscore apple as well, also lp underscore orange as well. Okay, so like this we have combined both the values together using the zip function for lp apple, lp orange, and we are getting two variables, apple Laplacian values and orange Laplacian values. Okay, now what we have to do is, okay, I'm going to take three variables. So one is the columns, another one is the rows for the image, and another one is the channel. Okay, so we have three variables which we have to get from this apple Laplacian image. So from this image shape we can get all three values. Okay, we can get all three values. Then finally what we have to do is, okay, whatever may be the size of this particular apple image or orange image, okay, we have to do exactly as half. Okay, exactly half of that. So what we have to do, what we are going to do here is, okay, let me just come here and say we are going to use the same np dot horizontal hack, okay, sorry, horizontal stack function, and I'll pass at that apple underscore lap and orange underscore lap variable as well. Okay, now what we are going to do here is we have to do exactly at half an hour. So I'm going to say use all the channels, okay, of the rows from 0 to last, and then the column wise you do from 0, but what you do is whatever the columns is there, okay, that you should divide it into half the value. So till there you will have to do this. But if you are doing this, okay, make sure you are getting the integer value of that. So let me typecast this as integer value. So this is what is going to happen from 0 till the half the columns of the image. It is going to take care of the apple image. So let me just show you till from the starting value till the half. Okay, it is going to take the values. Now what we have to do is for the orange thing, we have to start from the half the value till the end. So that is how we are going to start merging this apple Laplacian image. So first let me put that square bracket. I'm going to say all the rows for from the bottom to the till the last, and then I'm going to use the int function to typecast it for all the columns, divide by 2, and let's come here and put colon and just leave it like this as empty. Okay, so like this, here we are mentioning that it has to be from, this is from the starting range, and here empty means till the end. So this is how we are going to horizontally stack. Okay, now all you have to do is you can store this okay, as a variable Laplacian itself. Okay, and this Laplacian, okay, what it will going to do is it will be merging each and every layer. So this value will be layer by layer for 5 layers. So that is what we are going to be putting in this particular list. So here let me choose that variable name, that is the apple orange underscore merged, and let's append that Laplacian levels of those pyramids for the apple and orange image like this. Okay, so this is the fourth step of merging both of them together. But here one more thing what I'll do is I'll keep a variable name. Okay, I'll just keep a variable name saying that at the beginning we don't have any kind of layers, so n will be 0. Okay, and for each and every level, okay, each and every level, okay, for those rows and columns, okay, let's just increment that value of n to 1. Okay, so that we can keep track of the levels as well. So this is how we are going to combine or merge both of them exactly half in half. Okay, now final step, that is step number 5. Okay, that is the reconstruction of the original image. Reconstruction of the original image from the merged images, like this. So let's get on with the fifth step. So let's first take a variable called as a apple underscore orange underscore constructed, or construct, you can say like this. Okay, and then here, what first of all what we are going to do is we have got this apple pyramid. Okay, the orange and apple merged pyramid is there. Okay, so that is what we are going to keep here. Okay, and we are going to start with the first index of that. Okay, so like this. Now what we are going to do is, from I in range, I'm going to choose from 1 to 6 because I want from only 5 layers, so I'm choosing from 1 to 6. Okay, and I'm going to say in this apple underscore orange dot constructed. Okay, so let me just take this variable and put it over here, and we are going to use the cv2 pyramid up function and pass our apple variable constructor, this one, this variable. So let me just put it right back here. Okay, so layer by layer, so 5 times what it is going to do, it is going to start from the starting index, and then it will start from the 1 2 3 4 and fifth index, and keep on using this pyramid up function to reconstruct our particular image. Okay, then what we need to do is, in this variable itself, in this variable itself, okay, we are going to keep loading that layer by layer. Okay, we are going to keep adding that layer by layer by using the cv2.add function is there. Okay, and now what you have to do is both the images, okay, both the images which we got from this merged one and this constructed one. Okay, so first of all what you have to do is, first of all let me write this variable over here, and towards the left side, okay, layer by layer, what we have to do is, this merged list is there, right? That list, okay, we have to pass it over here, and since we are going to take layer by layer, I'm going to give it as I. Okay, so this I value is this particular thing which gives us 5 layers. So first layer constructed with the apple and orange constructor layer. Okay, so from the first index, so this is the index which we have passed here at the top. So this is how you reconstruct your image at every level of the merged pyramids together, and reconstruct like this. Okay, now let me just save the program and let's run the program once again. Okay, so as you can see here, we have the apple image. Okay, here we have the blended image, and here we have the orange image. Okay, we are not exactly showing as of now we are not shown the reconstructed image. So let me just add that code very fast. So this is the blended image, just like this. I'm going to copy this line, paste it over here, and here I'm going to give that reconstructed image. So apple underscore orange underscore construct, and here also I'll just name this as apple orange constructed image. That is going to be the heading of that window. So now let me just rerun the program, and this time, as you can see, we have got the fourth image, okay, which is blended together, okay, like this. Okay, using the pyramid techniques. Okay, so here we have the original orange image, on the right side we have the original, sorry, here on the left side we have the apple image, here on the right side we have the orange image, and here this is before using any pyramid schemes, and here is where I've used the both the Gaussian as well as the Laplacian pyramid, and reconstructed the image by doing the horizontal stack function. Okay, so this is how you can do the blending operation on images by using the pyramids. Now, the next topic I want to talk about is contours. So, So here I have a sample code, okay, just to show the images. And then first let me tell you what contours means. See, contours are the curves which are joining the continuous points along the boundary, which are having like the same color intensity, or which are having the same color, you can say. Okay, it will be like a continuous line, okay, which will be having the same boundary. Along the boundary, we can say. So this counter, okay, why it is so much useful in OpenCV is because, see, counters are useful for finding the shape and shape analysis of any kind of object which we are trying to detect. So that's why in object detection it is used very often. And if you want to recognize any particular object using its shape, then you need to know how to find the contours of that particular image. So right now I'm reading an image, okay, that is opencv logo.png image, okay. And whenever you are finding the contours, okay, it is found in grayscale. So we are just converting using the cvt color for this particular image into color bgr to gray. Okay, so this is the function we are going to use, and we are going to be having two images. One is the original image and one is the grayscale image. So I'm going to show both of them on the screen using the imshow function. One is the original image where I have passed img as the second parameter, and another one is the gray version of the image where I have passed this img gray version, and wait key for unlimited time unless we hit the escape button, and at the last destroy all windows. So this is a sample code, so let me just save it and let's run the code. Okay, so as you can see, this is the original image and this is the grayscale image of that particular variable. So let me just hit escape button and that thing will go away. So like this we have written a sample code for this one. Okay, so whenever we are finding contours, okay, we usually go with a binary version of that. Okay, so that's why it's in grayscale. But first, in order to find the contours, okay, what you have to do is from this grayscale image, okay, first you have to find the threshold level, okay, whichever you are going to set. Threshold level from, hey guys, the image properties, or you can say the image pixel starts from 0 to 256. So 0 to 255 you can say. But you need to have some kind of a threshold level, okay, so that you can say from, let's say, if I am taking like half of the points, like 127 till 255, you find the threshold level. So first you have to say finding the threshold of the grayscale image, like this. And let me just put it as the result variable. Okay, this is to find the threshold, and other one is the threshold level. So simply let me keep it as a thres threshold variable. Then from cv2 library, I'm going to use the threshold function. So one, it is saying the source on which you are going to find the threshold. So that is going to be our grayscale image. So image gray is the one which I'm going to pass as a first argument, and the lower level, let me just choose the half of 255. So let me simply choose it as 127, and the last part, let me choose it at 255. Okay, so there cannot be maximum level than this one. And here let me just correct the spelling, img gray. Okay, so these are the three parameters, and the fourth parameters will be the depth. So simply I'll give it keep it as 0. Okay, so this is the first step, okay, in order to find the contours. So first you will have to find the contours, and then let me write it here in comments, like now we are going to find the contours from the grayscale image. Let me save the file. So first let me just correct this spelling here, over here, contours. So first what we are going to do is we are going to say cv dot, okay, to find the contours we have this find contours function. So let me use that one. Okay, so first of all we will have to pass the image, okay, of which we want to find the contours of, and here this is the image, okay, this is the value which we are getting from the grayscale image. So this will be the first value which we are going to type. Okay, now the next value or the next parameter which you have to pass is the contour retrieval method. Okay, so in cv2 we have lots of methods in order to find the retrieval of this particular contours. So the parameter starts like this, retr, that is the retrieval. Okay, so we have so many retrieval functions, and this time I'm simply going to use the tree function. Okay, so let me type it here, retr underscore 3. Okay, so this is one of the contour retrieval modes, you can say, or methods like that. Okay, and the next parameter, okay, will be something called as uh, it's a method. Okay, it's a method, like it's a method to apply. Okay, it's a method we want to apply while we are getting the contours. Okay, it is also called as a contour approximation method. So in from CV2 library itself, I'm going to say get this chain, chain, chain underscore approx. Okay, there is a simple, there is this, and there is none also. For time being, we'll use this none value. Okay, so now this whole thing, okay, this find contours thing is going to give us two variables. Okay, so one is the contours. Okay, so let me just put it is here as contours. Okay, TOURS. Okay, and other one variable it is going to give us back is called as the hierarchy. So let me just name this variable as hierarchy itself, HARCHY. Okay, now you have to understand what exactly are these contours and what is this hierarchy which we are going to get from this find contours function. So let me just add it here in contours like this. Contours are nothing but, okay, it will be a list of all the contours, okay, from the image which we are going to fetch it from. Okay, and each value, okay, each contour, okay, will be let me write it here like this. Each value of contour COUR will be a numpy array of x and y coordinates. Okay, x and y coordinate of its uh, boundary, you can say, like the boundary points. So let me just say it here, boundary points. So like this, we will get all the contours. Okay, and now what is this hierarchy? So let me write it here in comment like this. Hierarchy is nothing but this will be like an output vector. Okay, this will be like an output vector which will contain, so which contains, okay, information. So let me write it here, information, T-I-O-N-A-B-O-U-T, about image topology. Okay, so this is how we are going to get these two values, that is the contour and the hierarchy, from the grayscale image which we have set the threshold from 127 to 255. And just for demonstration purpose, okay, let us find out how many contours have we found from this particular grayscale image which we have given here as THRESH threshold. Okay, so what I'll do, I'll simply say print, okay, total contours from image is like this. Okay, and let's come here, and first of all let's use the string and let's use the length function on this contours. Okay, and let's print it on the screen. And here I have just missed the plus symbol, so let me add it over there. Okay, and now let's save the program and let's run the program. Okay, so this is the grayscale image which we are feeding. So let me just go back to the output screen and check from this grayscale image. Okay, the total number of contours we have found is 19. Okay, so this is how we are going to find the total number of contours. So let me go back to the code. So now what we have to do is we have 19 contours, okay, and which we are supposed to draw on this original image. So for that, let me write it here in comments, like drawing the contours. Drawing the contours on the original image, that is IMG. Okay, so in order to do that, so you just have to use the draw contour functions, okay, on this particular image. Okay, and what we have to draw is the contours variable which we have kept, and we want to print all 19 of them, so till the last. So I'm going to give the next parameter as -1. -1 indicates till from the first contour till the 19th, and you just draw all the contours in some kind of a color. Okay, so you can just choose any color from BGR. Okay, so simply I'll put it as 0 comma 255 comma 0. Okay, this will give me bright color. Okay, and then the next parameter is the thickness. Okay, so let me just simply give it as 5 as the thickness for time being, and let's save the program. Now let's run the program and check how the contours are coming on top of the image like this. Okay, so this is the original image on which we have 19 contours, and this is what, okay, it's exactly it has printed on the screen. Okay, now let me just try out any different image. Okay, we have one more image of this opencv logo. So in the images folder, so let me say opencv white is there. So let me save it and let's run the code. Okay, so as you can see, we have this particular image, okay, on which we have drawn the contours, and this is the grayscale version of that. Okay, so this is how you can print okay, so this is how you can print the contours on those from the images itself. Okay, so what I'll do, I'll just try to change some color of this and show you much more properly. And let me just keep this as 255. Let me change this color to 0, and let's run the code once again. Okay, so let's run it. So as you can see, we have the blue color contours which got printed on this particular image like this. Okay, so this is how you are going to find the contours of your images. So in this video, you learned how to find the contours of any particular image. Okay, and this is highly useful in motion detection using the object detection using OpenCV library. Okay, so in the next topic, we are going to take a simple project. Okay, where we are going to find a motion of all the people who are walking around in a video or something like that. So let me just create a file for that. Just go to the file here. Let me and create a new Python file. Let's say motion detection on video using contours. So let me get rid of this output screen as well. So here I have a sample code. We have a video called as btest.avi, and we are going to run that program. Okay, we are going to capture that frame by frame, and we are going to show it on the screen. Okay, and we are going to wait for at least 40 milliseconds or until we press the escape button, that is the 27. Okay, so that is how we are going to read one video from this folder called as images, and then finally we have to release the captured videos also, as well as we are going to destroy all the windows as well. Okay, so this is a sample code for how to run a video file and how to show it on the screen. So let me just run the file very quickly and show you. So this is the video file which we have, and some people are moving inside that. Okay, now what we are going to achieve in this project is, see, whenever these people, okay, wherever these people are moving around, okay, we are going to capture the motion of that particular person or all the people, and we are going to put a square box around that particular person, whoever is moving around. Okay, so this is the final project which we are going to achieve. Okay, so first what we are going to do is, okay, we are going to capture frame by frame, okay, the video which we are seeing here on the screen which we are reading. Okay, I want to capture frame by frame. So what I'm going to do is, see, this code which gets me the result frame by frame, I'm going to copy it outside the while condition like this, and I'm going to create two frames. So frame 1, and this is going to be the frame 2. Now since we have done that, we don't need this line anymore inside the while condition anymore. Okay, now what I'm going to do is, I'm going to get the absolute difference between this frame 1 and this frame 2. So let me come up here and say, I'll simply keep a variable called as diff. Okay, and from cv2 library, okay, there is a function called as abs diff. Okay, so it asks for the frames, okay, which we want to find the difference of from the frame 1, okay, and frame 2. These are the parameters which we have to pass. Okay, now why we are doing this is because we want the grayscale image of this difference of this frame 1 and frame 2. So what we are going to do is cv2 dot, okay, convert color cvt color function is there. Okay, in that one I'm going to say I'm going to pass this difference of the frame 1 and frame 2, and you convert so cv2 dot, okay, I'm going to use the color underscore, okay, the blue, green and red, so bgr2, okay, grayscale gray. Okay, so this is how we are going to find out, okay, the grayscale image of this particular frame 1 to frame 2. And why we are finding the grayscale is because to find the contours. Find the contours from the grayscale image, or you can say it as frame. So that is why we have converted into the grayscale image over here. Then after getting the grayscale, okay, I'm going to perform the blur operation. So let me just create a variable called as blur itself, blur operation. Okay, so let me come up here and create that variable over here called as blur, and from cv2 we are going to use the Gaussian blur function, okay, and in which we are going to pass our grayscale image, and the next parameter is the kernel size which we want to apply on our image or the frame by frame, and the alpha value which I'm going to keep it as 0 for time being. So this is how I'm going to blur our particular images. So after blurring the image, okay, the next operation I want to perform is to find all the threshold values. Okay, I'm going to find the threshold. So for that, first of all, I'm going to keep a variable for the result for the threshold, and to store the threshold, I'm going to create a variable called as thresh is equal to from cv2 library. I'm going to use the threshold function, and in this one, okay, I'm going to pass my blurred image. So this is the variable which we have got from the blurred image like this. And the next one, we have the counter values which starts from 0 to the highest point 255, okay, from the absolute dark to the absolute white. But here instead of choosing 0 for time being, we'll choose it as 0, sorry, 20. And then finally the method in which we are going to apply. Okay, so we have cv2 dot, okay, the threshold value for binary is there, triangle is there, so we are going to use this one. We are going to use the binary threshold binary to get the threshold values from the blurred image or the smoothened image, you can say. And now the next step here I want to perform is called as dilate. Okay, this helps in finding out the contours much more properly. So what I'll do is I'll create a variable called as dilated, and I'm going to use cv2 dot dilate function is there, okay, in which we are going to pass our thresholded image, so thresh, that is the image. And here one more parameter, I'm simply going to pass it as none, and this none value I'm giving it for the kernel size. Okay, for time being we are not going to mention any kind of kernel we are applying on the dilated images or the threshold images or not. So this value will refer to the kernel size itself. Okay, and the next value here as a parameter I'm going to pass is the number of iterations. Iterations is equal to, you can choose 1, 2, 3, 4, 5, anything. For time being we can choose as 3. Now the final step left for us to do is find the contours. So let me just write it here in comments. Find contours. Okay. Now we are going to use the cv2 dot find contours function, okay, in which we have to pass our dilated image. Okay, and then the next parameter is the mode in which we are going to retrieve. So we have retr, it stands for retrieve, and we can use either tree, list, external, and this time I'm going to use the tree function. And you have to understand that this is going to give you two parameters. One is the contours. So let me just create a variable on the left side called as contours itself. Okay, then the next variable is the hierarchy. So I don't need hierarchy, so I'll simply put it as underscore over here and just put it like this. And the third parameter in this one, we will have to give the method how it has to give the approximation result. So cv2 dot, okay, there is a function called as chain underscore approximate none simple, all those things. So this time let me use this simple method to find the contours of the image. So after finding the contours, we just have to draw it on the original frame which we want to do. So for that we just have a function called as draw contours, okay, and it is going to ask from which frame you want to draw the contours to. So I'm going to give it as frame 1 for time being. And what are the contours? So what are the contours which you want to apply on the frame 1? So these are the contours which we are going to get from the previous line. So you will have to pass that as the second argument. And now since you want all the contours to get printed, you will have to pass it as -1. And then finally the next argument will be the color. So let me choose it in green color. So I'll pass 0 comma 5 comma 0. So this is going to give me the green color. And the next argument is going to be the thickness of the contour. Like you can give 2, 3, 4, 5, anything as per requirement. Now what I'll do is, okay, I'm going to show that frame 1, okay, which it is going to capture again and again, okay, while the frame is being captured over here. Okay, so instead of showing this as frame, okay, I'm going to say feed over here. That will be the display window name. And here I'm going to show it as frame 1. Okay, and still now what it is going to do, it is going to the frame 2 also, frame 3 also, like this. It is one by one, it is going to capture all the frames. So what I'm going to do is this frame 2 which we have captured. Okay, first what we will do, I'll just store it in frame 1. Okay, let me just make this as like this. And on the frame 1 we are finding all the contours. We are showing that this is the two uh, thickness of green color which we want on that frame 1 which you are reading. Okay, so frame at frame 1. Okay, so again and again. So next what we have to do is that result, okay, result of this frame 2 we are going to get captured by saying capture dot read function. So it is going to keep on reading a second frame, and it is going to keep on feeding it to the as frame 1. And finally frame 2 also we are going to keep reading while we are seeing the entire video again and again, frame by frame. So now let me just save this program and let's run the program and check what will be the result. Okay, so it's saying we don't have any attribute called as dilate. Okay, I think we have made some kind of a spelling mistake. And let's see, it says here in line number 18 we have done. So dilate. Okay, so let's check that what is the problem over here. Okay, here I have made a simple spelling mistake. That is not dilate, it's dilate. That's it. Okay, now let me save the program and let's rerun the code. Okay, so this is our video. So as you can see, it has put 2 mm thickness on each and every contours. Okay, that is the contour. And on each and every moving object or person from this particular video. So as you can see, even the ropes are moving up. So whenever the rope moves, okay, it is going to put a 2 mm thickness. So as you can see in this code, line number 22, we have again 2 mm thickness of green color and putting all the contours on frame 1. Okay, and here you can notice that this frame 2, okay, frame 2 means the next frame, it is getting copied in frame 1 again and again. And the frame 2 is what we are reading and storing it in frame 1 while we are capturing this video till the end. And this is how you are going to get the object detection part, okay, the motion detection part in this particular project. But this is not the final result we actually wanted. Okay, let me just show you one more time. We want a rectangle on each and every moving part, okay, and maybe not on the ropes, okay, because ropes are moving very slowly, but still it is identifying the motion of the ropes as well, because we are given the values like that. Because now it is trying to search for each and every motion of each and every object which it finds in the particular video. Okay, so let's rectify that code right now. So let me just press escape button and that code will stop. Let me just remove this output screen also. Now let's continue. So now you came to know that this line, okay, this line draws the green color border around all the moving objects. Okay, and this time I don't want to see the moving objects like that. Okay, I just want to see a rectangle on top of all the contours. Okay, and what I'll do is I'll just loop through each and every contour. So I'll say for each contour, okay, for each contour in contours. Okay, that is a variable name which we have taken over here. Okay, we are going to loop through each of these contours, okay, like this, and we are going to create a rectangle. So we are going to draw a rectangle on each and every contour instead of giving just the contour, or even just drawing a contour on each and every moving part. So for that, what we need to do here is, okay, first of all, we have to mention the x and y, the coordinates where we want to start putting the rectangle. And then we have to choose the width. So I'll keep it as W, and height of that rectangle as well. Okay, so these are the 4 points which we need to draw the rectangle. But how to get these values is by using CV2 libraries. One bounding, there is one function called as bounding rect. Okay, that is rect stands for rectangle, and it is going to find these values, the width, the height, x and y direction from each and every contour. So this variable has to be passed inside this particular function like this. Now, after giving this height, weight, x and y, okay, what we need to find out is here we need to find the area. Okay, we are going to find the total area, okay, on which we need to see the square on that. Okay, and I'm going to use this in an if condition, saying that if first of all, to find the area, we have that contour area function. Okay, so let me just say contour area. Okay, so I'm going to find the contour area for each and every contour. So let me just copy this and paste it over here. Okay, and I'm going to say, like, if the area is like less than 700 or 600, something like that. So let me just take it as 700. Okay, if the area is too small, or if it is less than 700, then no need to do any kind of square boxes. So I'll simply put the continuous statement over here. Okay, or else if it is greater than 700 means, then what I'll do, I'll draw a rectangle on top of that. Okay, on the moving object. So cv2 dot rectangle is the method to draw on the frame 1. Okay, on all the moving parts. Okay, so here the first argument will be the x and y coordinates from the where the square has to start and it has to end at this point, that is whatever the x coordinate is there plus the width. Okay, and the next argument will be whatever the height of the argument is there, that is y plus the, sorry, y coordinate and the height. So this is going to be the second argument. It's going to start from this and end it at this point, the rectangle. Okay, next value will be the color. So let me just choose the green color once again. So 0 comma 255 comma 0. So this is going to be the color of the rectangle. And now, after giving the color, okay, or choosing the color as green, I'm going to give the final argument, that is the thickness. So let me just put it as 2 for time being, and later on we'll check whether the thickness is okay or not. Okay, so this defines our rectangle perfectly. And whenever there is one person moving, okay, what we'll do is we'll put some text on the screen saying that using the put text function on the frame 1, and I'll simply say the status, whether it is moving or not. So status is equal to, like this, and in curly braces like this. Okay, I'm going to string format the result. So I'm going to say format. Okay, we have to say whenever the movement is there, we have to say movement is, and this will be the first argument. And next we have to decide where exactly this text is going to appear. So I'll simply give it as a 10 comma 20 for the x and y coordinates. There the text is going to come. And then next we have to tell the font type. So I'll simply say font underscore Hershey's simplex is there, you can use that one, or italics or anything like that. And then the next one, okay, is the font scale. So let me just put it as 1, and the next argument is going to be the color, in which color you want to see. So let me choose this one as red. So let me say 0 comma 0 comma 255. Let me go to the last, and finally let's decide on the thickness of the text which we want to see. So I'll simply give it as 2 itself, and let's check our result. So this is all commented out. So let's run the code. So as you can see, it's putting a perfect rectangle on all the moving objects and people in this particular video. Okay, and as you can see right now, the rope which was moving little bit, okay, we have reduced that noise as well. Okay, and here at the status at the top, it says status equal to movement. Okay, it's exactly very at the top. Okay, so what I'll do is I'll just increase the font scale, this one, to 20 comma 20. So both x and y directions I have given as 20 comma 20, and let's run the code once again. Okay, so as you can see, x and y, okay, y still remains 20 itself, so the height value I'll give as 40, the y direction. So now let me run the code. Okay, so as you can see, the status move coming like, okay, and it will be much better if this also is coming in green color, but it is not that visible. So let's give this color as 255 as well, like this, and here let's put it as 0. So now let's run the code once again. Right click, run motion detection. Okay, so as you can see, we have changed the color of the text to a movement, and as we are seeing, it is giving a rectangular box, okay, on all the people who are moving. Okay, and we still have little bit of noise when these ropes are moving left and right because of the wind. Okay, so can just rectify that also, and we can also choose one more thing, that the area. Okay, the area of the contour can increase or decrease. Let's say we have 900. Okay, we have 900, then it has to do nothing. Okay, if it is less than 900, then it will not do anything, but if it is greater than 900, then only it will put a rectangular box around that. Okay, so as you can see now, we have we have the greater rectangular on each and every person whenever they are walking, because the area now has been increased. So this is how we can put rectangular boxes around our moving objects. Here, one more advantage of increasing the size of the area, contour area, is like, let me just rerun this program once again. Okay, so as you can see, these ropes, okay, earlier we had these ropes also had that earlier green color contours on top of that. Okay, now because the area has been increased, okay, we are not getting any kind of noise anymore. Okay, noise is nothing but we have removed the contours from those ropes. Okay, so this is how we can find, okay, this is how we can find or have a motion detection project using opencv library. So we have successfully completed this motion detection project using opencv, and now, okay, thank you very much for watching this video. Okay, I'll see you in the next videos where I'm going to different kinds of projects using opencv. Thank you very much.